Just like with measurement, anytime that you construct something or design something, you need to be aware of the tolerance. Tolerance is how far off or how far out you might be, and your construction or your design or your build is still okay. If I'm building a house, it might be okay if I'm off by 1/8 of an inch. But if I'm building aircraft parts, it's probably not okay if I'm off by 1/8 of an inch. Similarly, if I'm building a road, it might be perfectly okay if the edge of the road is 1 inch off of where I expected. However, if I'm building a cell phone, 1 inch is way too far off, and you're looking at things in the nanometers for the construction of computer chips. So when I'm looking at tolerance, there's a couple of terms you should know. The nominal value is the designed value. If I want my wall to be 8 feet long, that's my nominal value. I might also have a minimum and a maximum that are acceptable. If I'm designing something to be 12 feet long, but I'm okay if it's 11 foot 8 inches or 12 foot 3 inches, there's my minimum and my maximum. Those are the minimum and maximum acceptable values. If you build something and it's outside of those values, it's not acceptable and you would reject it. If you have, for example, a chocolate bar and it's listed as being 65 grams, that would be your nominal value. If the acceptable range is, say, 62 to 69 grams, that would be your minimum and your maximum. Your tolerance is the distance from your minimum to your maximum. So you take your maximum value and subtract your minimum value. This is how far, or the range of acceptable values. If something is not within the range of tolerance, you would reject it. If you make a chocolate bar that is too light or too heavy, you would reject it and you would not sell it. Similarly, if you make a computer chip and it's out of tolerances, it probably won't work, so you need to reject it. Tolerance can be written in many, many different formats. Here are 3 formats that we will use in this course. These are 3 formats that you may see on the exam. There are hundreds of more formats for tolerances that are different depending on what industry you're in, what you're working with, even when you're looking at different countries, they have different formats for tolerance. The medical profession uses quite different writing for tolerances than does, for example, an engineering firm. They mean the same thing, but when you're constructing different things, you write it and you treat tolerance a little bit differently. It's the same concept, however. So the first form here is really straightforward. I'm going to write this down as we go. Let's say that I have a chocolate bar and the nominal value is supposed to be 65 grams. Let's say my minimum is supposed to be 63 grams and my maximum is going to be 67 grams. So anything in between 63 and 67 grams, we would accept as being close enough. This, if you actually go measure chocolate bars, they're not exactly the correct weight all of the time. They'll be off by a little bit, but that's okay. When I'm looking at this, the first way to write tolerance is that I should actually calculate my tolerance. My tolerance in this case is just going to be 67 minus 63. So my tolerance is going to be 4 grams. This is just the range of acceptable values. I have a tolerance of 4 grams. If I want to write this in the first format, this is by far the easiest format. So I'm just going to write 67 over 63 and then my units as grams. That is a correct form of tolerance. It won't always be the form that you are asked for in questions, but it is indeed a correct form. Now, the second form is the most, I find the most common one. This you treat as two little math problems. You have a nominal value and you say how much can you go up and how much can you go down from there. These little math problems must result in your minimum and your maximum. So if I start off and I say my nominal value is 65 grams, I can go up plus 2 or down minus 2. This results in my tolerance here. A couple things to note. 65 plus 2 works out to my max of 67. 65 minus 2 works out to my minimum of 63. If I add these two together, that gets me my tolerance. So 2 plus 2 gets me my tolerance of 4 grams. Tolerance. This is not the only way that I could write this. Depending on your industry, depending on your profession and the use of this, you may find that your nominal value is not smack dab in the middle. So for example, I could also write this as 67, say that the top end is important. I can't go up at all from there, but I can go down 4 grams. Great. Or similarly, I could write 63 plus 4 but minus 0 grams. All three of these say the same thing. Notice that in all cases, these parts here add up to the tolerance. And in all cases, this plus this works out to the max. This plus this works out to the minimum, or this minus that. So these all work, and that's not the only ones. I can choose anything in there. I could do, for example, 64 plus 3 minus 1 grams. All of these mean the same thing. I treat it as little math problems. One thing to note where the 0 is. That will give you some hints as to how this should work. Now the third form says, hey, look at this here. I have 65 plus 2 and minus 2. Well, I know that I can do that in the similar format to my uncertainty, so I could write 65 plus or minus 2 grams. This is useful because this is reminiscent, this is related to our measurement and uncertainty format. But what we have here, this is halfway between our maximum and our minimum. So this is what we call our midpoint. Now, another way to find that is I can go max plus minimum divided by 2. I'm finding the midpoint between my maximum and my minimum. This here, my uncertainty, just like the uncertainty when we're talking about precision, is half of the precision. In this case, this is my tolerance divided by 2. So it's half of my tolerance. All of these formats are stating the same measurement. All of these say the same thing. They're all treated like little math problems. Just adding and subtracting. The trick with tolerance is making sure that you're reading this correctly. Let's look at a couple examples here to see how this works. So, a car part has a maximum size of 6.5 centimeters and a minimum size of 6.3 centimeters. State this in the form A and then B over 0. Here with this form, if you note, this is like our second forms here where I have little math problems. However, if you notice there's a 0 on the bottom, which means it's going to be like this form here because there's a 0 on the bottom. So what that means is that my A value there has to be my minimum because I can't go any further down from there. So I'm going to write this as 6.3 millimeters. That's the A value because that's where I'm starting at. I know that this on the bottom has to be 0 because I can't go down from there at all. So that has to be the minimum. Now, to get to the maximum, I have to make a little math problem where I go 6.3 plus something gets me to 6.5. In this case, plus 0.2. Now, I found that out by going 6.5 minus 6.3, and that gets me a 0.2. And I can write my units here like this. That works too. This works great. I've got this plus this works out to my maximum. This minus that works out to my minimum. This is a good way to write tolerance. Let's look at another example that's a little different. So we have an employee doing quality control at a screw factory and uses the following measurements to check the diameter of the screws. So their design or their nominal value is 7.85 millimeters. Great. And the measurement can be 0.12 millimeters larger or 0.06 millimeters smaller. So if I write this out, 7.85 millimeters plus 0.12 millimeters minus 0.06 millimeters. My tolerance here would be the range from maximum to minimum. I have two ways I can find this out. The first way, which will always work, is I can go 7.85 plus 0.12. So my maximum is going to be 7.97. And my minimum would be that minus that. So 7.79. And then I can subtract them. So 7.97 minus 7.79 equals 0.18 millimeters. That always works. So there's my tolerance. However, because I know how this format works, when we looked up here, these two parts here I can add to get to my tolerance. So if I look at just that part, I can go and say 0.12 plus 0.06 gets me 0.18 millimeters, and that there is also my tolerance. Both methods work correctly. Tolerance is the trickiest concept in this unit, and tolerance is something that is definitely worth taking a look at and making sure you understand before you move on. The actual math involved is nothing more than addition and subtraction, which you have been doing for a long time now, but it's making sure you're knowing what to add and what to subtract. The tricky part with tolerance is understanding where your minimum and your maximum and your tolerance are, how they're related to each other. Take your time for questions like this, and I hope you have a great day.